All right, so the next thing we're going to look at here is the extreme value theorem. And the setup for this is just that you have to have a continuous function on some interval. So f of x is continuous on the interval from a to b. By the way, those are two different x values, so it's like x1, x2 there. So if f of x is continuous on that interval, then we can say that f has an absolute maximum value and an absolute minimum value. So absolute minimum value in that interval. Okay, so this actually goes back to the question that someone asked in the chat while we were on our little break between videos there, as to whether every problem was going to have both absolute and local maximums and minimums. This theorem is actually what guarantees us the absolute maximum and absolute minimum as long as the function is continuous on our interval. So the local maximum minimum thing, by the way, still not guaranteed. It may or may not have those. But from this, we at least know it'll have an absolute max and an absolute min. So I think that actually helps with that question quite a bit. Cool. So we have a couple different possibilities for where we could see that absolute maximum and minimum. So I'll kind of sketch out our different options here, some little graphs. Let's see. Okay, so let's give ourselves an interval from A to B. All right, and a pretty simple function here. Okay. So if our function looks like that, we are just focusing in on the interval from A to B. So just between those green lines, all right, even though the function continues outside of that. We can see that the function is actually continuous on that interval. Just from looking at the graph, there are no breaks or holes in the function. So that's good. It meets our criteria here for the extreme value theorem. So this function is going to have an absolute maximum and an absolute minimum value in our interval. This up here would be the absolute maximum value. Right on the end of the interval there. This is our abs max. Okay, because that is actually the highest, greatest value of the function over that entire interval. Okay, and similarly, here's our absolute minimum down here. It's also at the other end of the interval. Okay. So we could see that, yeah, your absolute maximum and your absolute minimum could be happening at the endpoints of that interval. All right, so there's one scenario. For our next scenario, let's set it up again, same type of way. Got an interval from A to B, and let's make the function a little more interesting this time. Let's say it does something like this. Let me make that a little more pronounced. Okay. Maybe something like that. Okay. There's a function. And again, we just want to focus on the interval from A to B. So between the green lines. All right, and once again, just kind of double checking there, this function is actually continuous on that interval. No breaks, no holes, so we're good. Make it a little smoother right there. All right. And so we are going to have an absolute maximum value and an absolute minimum value in our interval. So our absolute minimum, we can see, to start with the smallest value, that would be at an endpoint again here. That would be the function value at b. There's our minimum, absolute minimum. Okay, that's the smallest y value. And our absolute max now is up at the top of the hill here, right up there. Absolute max value. So that is not at either endpoint. It's somewhere in between. Okay. So that's a possibility. And for the last possibility here, we'll sketch another graph. Give us an interval a to b. And let's see. Our function this time, I see I've got a question in the chat there. Let me sketch this graph out, and then I think we can pick into this middle graph a little bit more here. This might actually clarify though. Let's see. Okay, so for our last graph here, let me make it a little curvier, and we'll go something like this. Okay, there. Maybe. Your functions don't have to be like anything special here. I'm just being a little bit picky since we're trying to take notes on this stuff. Okay, I think this one will work nicely. All right, so there's a nice function there. I don't know what the actual formula for that function would be. It's kind of weird looking, but we're just focusing on the interval here from A to B. And we would like to look for our extreme values. It is a continuous function. Even if we don't know what its formula is, we can identify that there are no breaks, holes, vertical asymptotes, anything going on there. So we are going to have an absolute maximum and an absolute minimum, but it just so happens here that neither of those are at the endpoints. Our absolute maximum is up here, top of the hill. Absolute maximum value, that's the highest y value for this interval. And here is our absolute minimum. Okay, at the bottom of the valley, absolute minimum. And the endpoints are nothing significant. They're just kind of these in between, not extreme values. Nothing special is really happening there. They're not even local maximums and minimums because, like, if you look at this point right here, it is not the highest or the lowest thing in its own little area, really. Yeah, if you look at this part of the function, it's higher. If you look in this direction, or sorry, if you look this way, this value is lower than the ones to come. If you look backwards that way, this circled value is higher than those. So it's not really higher, lower, extreme for either direction there. So that endpoint is not, whoa, there went the function. That endpoint of the interval there is not anything that we would really label. It's not absolute maximum and minimum, and it's not a local maximum or minimum either. So I think that was what the question in the chat was looking at here on the middle graph at A. They were asking whether this endpoint here would be a local maximum, it looks like. So yeah, it would not be a local maximum or minimum there. It's just kind of the endpoint of the interval. and we wouldn't really label it as an extreme value in either case, because it's not like higher or lower than the things around it, and it's definitely not higher or lower than everything in that interval. So yeah. All right, so yeah, sometimes the endpoints don't really get any love or labels. They're just values at the endpoints. So yeah. But for the absolute maximum and minimum values, we've got kind of some different scenarios here. We could see that they can happen at the endpoints. Okay, they could both be at endpoints. All right. You could have just one of those values in an endpoint, either the maximum or minimum, and then the other one is somewhere in between. Or you could have neither of the endpoints being anything special, and your absolute maximum and absolute minimum are both somewhere in the middle of the interval. So that kind of keeps things a little bit interesting. There's no direct guarantee that we can see from these three examples that we will always get them at the endpoints or something like that. So these values, for the extreme values, can occur at the endpoints, potentially, okay, of the interval. Or they could occur somewhere in between. Okay. So that's the part that kind of begs the question right there. If these values are going to occur somewhere in between, we need to know how to find those values. Where are these going to be? How would you find like the X value for something like this? If it's just some point in the middle of the interval, we need to know how to find that. So let's kind of look at this for a second here. And let's see, okay, for the absolute maximum and minimum values that are not at the endpoints. So that would be this guy right here. My highlighter is still being really crazy. That value right there and this value right here. Okay, so those are the ones that are not at the endpoints. Is there anything that all three of those have in common? There is a little something, and as a hint to let you guys think about it, the something in common between all three of those, it relates to the derivative. So let's think for a sec, you guys who are on the call here. What would those have in common, do you think? I'll take a little water break here and see if anyone comes up with it. You guys who are watching this later on YouTube, you take a chance to think about this right now too. What's in common between the three green points there? Something that relates to the derivative in common between all three. I'll even pause the recording for a second here. I won't totally stop it, but I'll pause it. Okay, so here's the big reveal. What's in common between our 3 points there, the absolute maximums and minimums that are not at the endpoints of the interval? If you look at the tangent lines to those functions, okay, so the tangent line here would come across like this. The tangent line here would be just right kissing the top of that function there. All right, here's the tangent line for the absolute minimum there. You might notice that all three of those tangent lines are perfectly horizontal. So the derivative there, the slope of those tangent lines, is all 0. So the derivative is 0 at every one of those 3 points in our pictures, because they all three have horizontal tangent lines. And that's what we're going to use here to help us locate those absolute maximum and minimum points if they're not at the end points of the interval. So yeah, so look at the horizontal tangent lines. I'll make that little note here. Okay, look at horizontal tangent lines, because that is going to mark kind of like the top of the hill, bottom of the valley type situations that we have going on there. All right, so I'll stop our recording here for another minute and we'll get a clarification of what we're looking at there.